All right, good morning, kids. Now we're going to learn about exponential decay. In the last one, we learned about exponential growth. That would look like this. If you had an initial value of 5 and you were constantly doubling, you would start with a y-intercept of 5. I'll place that here. And then every step along the way, you're doubling. And previous amounts would have been half that amount, so on and so forth. And it would have looked like this. So now, let's see if we can erase that. Now in this instance, we'll say you have an initial amount of 10, and you're constantly multiplying by half. Each step of the way, you have half of what you previously have. When you substitute 0 in there, half to the power of 0 is 1. 10 times 1 is 10. So you still have a y-intercept of 10, or an initial value of 10. Place that here. Each step along the way, you're constantly multiplying by half. So you have half as much as you previously had, and so on and so forth. When you use negative numbers, what you get is half to the power of negative 1, which is the reciprocal of half. So when you use negative numbers now, it's like you're doubling. You have twice what you previously had, and so on and so forth. This function would look like this. So decay is a situation in which it moves towards the x-axis. Growth is a situation in which it moves away from the x-axis. In general, you could have some initial amount and then some decay factor. And the number just has to be less than 1. So in this instance, you still have an initial value of 100. That's always your y-intercept. And just randomly, I'll place that here. Doesn't really matter where you put it. The next value, you're going to multiply by 0.75, which is 75, so that's lower. And if you continue to multiply by 0.75, you get values that are lower and lower and lower. The domain is all real numbers. The range is everything above 0. What you're doing, this is kind of like the sale price of a shirt. You're not losing 75%, because from here to here, you didn't lose most of its value. You lost a little of its value. So if you think about it, you're retaining 75% of its value, and you lost 25% of its value. So on today's assignment, there's going to be a problem that says, what if you had a car that was initially worth $20,000 and it loses 20% of its value each stage? The function could be written like this. Your initial value is 20,000. When you lose 20%, you got to think about what percent you retain. You keep 80%. And that, all you have to do is just that math right there. 1 minus the 20%. So the function would be 20,000 times 0.8 or 0.80 to the power of x. Would be graphed like such. Your y-intercept is 20,000. You really have no values in this situation. Nothing to the left of the y-axis. There was no larger value previous to year 0. You're just working from here on towards the future. And yeah, theoretically, that's how car values drop. The only other tricky thing in today's assignment is that if they give you a function that looks like, let's say this, you see that your decay factor is 2/5. Since it's less than 1, that means your function is moving towards the x-axis. but they don't explicitly tell you the initial value. If they don't tell you that, you can put a 1 there. So then on your y-axis, you can graph the point 0, 1. That's where 1 is. And then all you basically have to know is that it moves towards the x-axis like such. Similarly, if they give you a function like this, the opposite of 1/3 to the power of x, to explicitly see your y-intercept, you can put a 1 there, meaning, and really in this case, your y-intercept is -1. I'll put it here. And 1/3 of -1 is -1/3, and 1/3 of -1/3 is -1/9. So again, your function starts away from the y-axis and moves, away from the x-axis and moves towards it. Your domain in this case is still all real numbers. The range is everything below 0. Can be hard to just see what your initial value is. That initial value or y-intercept is right there. Those two things are the same thing. All right, good luck. Email me if you have any questions.